Okay. What's your question on page 14? So,
It's question 4I. Yeah, that one.
yeah, for I.
Yeah.
Yep, okay. So, hey, come on. For I. So we want to calculate A multiply B multiply C. Just so you know, that's the same as A multiply B multiply C. Or, in fact, you get the same answer if you do it this way. So last time we saw that if you swap them, you get a different answer. Not allowed.
Yeah.
But you're allowed to put the brackets anywhere. You get the same answer. So if I do AB first, let's see. So A, 3, 1, 4, 1. And then B, 2, 2, minus 1, 0. Multiply C, which is 1, 2. So that would be 6 minus 1 is 5. 6 and 0, 6. 8 minus 1 is 7 and 8. Yeah? Multiply 1, 2. So that would be 5 and 12, 17. 7 and 16, 23.
Yeah.
Yeah. So that's the answer then. Anything else from that? No? Okay. If not, then we'll just look at the next one. Okay, so write that down, please. Okay. Now, last day somebody asked, maybe actually a couple of people, if we do division. So when it comes to matrices, we know how to add, subtract, and multiply. But then what about divide? So with matrices, we can't really divide them, but there is something that's like division that we can do, which is called inverting. So before we go on to inverse, which is like division, I just need to talk a little bit about determinants, okay? So let me just scroll down here. Do you have this example yet? Okay. So let's take two lines as an example. AX plus BY equals P, and CX plus DY equals Q. So there are two lines. These lines will always meet except when, so when do they not meet? If they're parallel. So that's what I want to look at. That they do not meet. And if they don't meet, then it has no answer when you try to solve it. So if they don't meet, then that means they're parallel. So first let's get the slope. I have BY equals minus AX plus P, and then I have DY equals minus CX plus Q. So I get Y equals minus A over BX plus P over B. Y equals minus C over dx plus Q over D. Now remember I said they don't meet, so that means they're parallel. So therefore, minus A over B equals minus C over D. And multiply both sides by minus. So it's positive now. I bring the D up here and the B up here. What's the verb for this? Cross multiply. So I get AD equals BC, which means AD minus BC equals 0. That's an important idea. It means that two lines are parallel and don't meet if this is true. So for example, if I wrote down 2x plus 3y equals 5, and then, I don't know, x, well, no. Let's say, let's make 15. Okay, so then 5x, no, not 15, I need an even number, 18. 6x plus 9y equals 1. I know that this has no answer because I can do this in my head. I can go a multiply d, what's that? 18, minus b multiply c, which is 18, and that equals 0. So I know these lines are parallel. I know they have no inverse. So this is important because it gives us a way to check if there's an answer or no answer before we start. Okay? Yeah. I'm going to do the next part now. Did you write that down? Or do you need me to scroll up or something? Yeah. Okay, so scrolling down now. So let's go back to my example at the start. Let's multiply this. So if I multiply this, what do I get first? AX plus by, and then underneath what do I get? Cx plus dy. Now you realize now if I write here equals PQ, then I actually have two statements. Statement 1, statement 2. I'm saying AX plus BY equals P and Cx plus dy equals Q. So the point I'm trying to make is my two equations I showed you a moment ago, I can write those two equations as this one equation here using matrices. Okay, and just to give you some letters, we usually call this matrix here with the numbers A, B, C, D in it A. We usually call this matrix here with the X and the Y in it big X. And then this one here we usually call B. So in other words, I can, if I scroll back up here, I can write this as a matrix, AX equals B. And this A has A, B, C, D in it. This X has X, Y in it. And then this B has P and Q in it. Okay, so let me go back down. Right, so that's important. So make note of that as well. So what I'm saying is that is the same as that, which is in other words the same as that, which is, they're all the same. They all mean the same thing. Okay. You got that? Yeah? Nearly? Okay, so if you remember, I said AD minus BC. If it equals 0, what happens? Yeah, parallel, so there's no solution. And if it's not 0, then it's not parallel, so then there is a solution. Okay? So this gives us our new idea. If I have an equation like this, A, B, C, D, xy equals pq, and I want to know if this has an answer or no answer, I just need to check this here. So we use something called the determinant of the matrix. And the determinant of the matrix is this formula, AD minus BC. And you might think, why is it this formula? Well, I kind of gave you a reason earlier. The reason it's this formula is because if this equals 0, then it has no solution. And if it's not 0, then it does have a solution. So if you want to check if you have a solution, you just need to calculate what's called the determinant, which is this formula here. Yes? No? Okay. Let me give you an example. So, if I go down, 4, 1, 2, 3, xy equals 1, 2. You can write that also as 4x plus y equals 1 and 2x plus 3y equals 2. They're the same. Now, I want to check if this has an answer. So I just go determinant 4, 1, 2, 3. That will equal 12. What's next? Plus or minus? Minus 2 equals 10, which is not 0. So does this have a solution? Will the lines meet?
Yeah.
Yes. Now, if I do an example like this, would something like this have a solution? Let's check it. It wouldn't, because that would be 8 minus 8, which is 0. So this has no solution. And what's interesting, well, notice here that I don't even need to know I don't even need to use these numbers. The only thing that determines if I have an inverse or not, if I have a solution or not, are the numbers here. I just need to check these 4 numbers. And if they have a determinant of 0, it has no solution. And if it's not 0, then it does have a solution. Okay. So for the first exercise, all I want you to do, I'll do an example, is just to calculate the determinant. So for example here, and there's 2 different ways to write determinant. You can write it with straight lines like this. So that would be 0 minus 4, which is 4. And then the next one, determinant 6, 2 minus 6, 2. That would be 12. Yeah. Minus 12, which is 24. So that's all I want you to do for the first question, is to calculate the determinant. Okay. How far now? Here? A bit more. Can you still see that? Yeah. Okay, so now let's look at the division. Can I scroll down? Okay. So this here, hey, listen. This here is just normal algebra. Let's pretend we can't divide. So if I just want x, what I would like to do is just divide by 2. Yep? But let's pretend we can't do this. So what number should I multiply both sides by to cancel the 2? Yeah. Or as a decimal, 0.5. So you see, if I multiply both sides by 0.5, they cancel, and I'm left with x equals 1.5. So this is just vocabulary. The 0.5 is called the inverse of 2. And the reason it's called the inverse of 2 is they both cancel to make 1. Okay? But I mean, you know that already, because if I do 2 to the power of minus 1, that equals 0.5. Anyways, don't worry about that. What I just want to show you there is this vocabulary inverse. Okay? Inverse is the noun. What's the verb of inverse? Anyone know? Invert. Yeah, with a T. So inverse is the noun and invert is the verb. Okay? Right. Can I scroll down? Yeah. Okay. Now, maybe somebody, well, maybe some people know this already, but imagine I want to put some numbers here so that when I multiply, I still have A, B, C, D. So you might think, oh, that's easy. Maybe I'll just put 1, 1, 1, 1. But that doesn't work. And let's see why it doesn't work. So if I do this, multiply this, what do I get? A plus C. So you don't actually want the C. So there shouldn't be a 1 here. Should be, 0, yeah. 1, 0, 0, 1. If you multiply these two, you get A, B, C, D. Okay? So, this matrix here, 1, 0, 0, 1, this is like, quotation marks, 1. Identity is the vocabulary here, yeah. Do you understand what I mean when I say it's like 1? Because when I multiply, it doesn't change. Just like the number 1 for algebra. So this has a special letter. This matrix here, we call it I for identity. So I equals 1, 0, 0, 1. And what's special about I is that I multiply A or A multiply I, still just A. Doesn't change. It's just like the number 1 in algebra. 1x equals x1 equals x. It's the same idea. So remember I said if you swap, it makes a different matrix. Yep. That's true most of the time. Here's a special exception of when you can swap and it still works out to be the same. Yeah? A special case. Okay. Now let me give you an example here. I would like everybody to multiply these two together for me. So let's see. Multiply, please. You will discover yourself when you multiply them. Yeah.
What's the...
Oh, A, sorry, maybe I should be a bit clearer. A is any 2 by 2 matrix. So it can be any 2 by 2 matrix. Usually in maths we use big letters for matrix and small letters for single numbers. Okay. So what do we get here? 1, 0, 0, 1.
So it means that one of the matrices is inverse.
That's it. It would mean that this matrix is the inverse of that matrix. Or vice versa. It could mean that this matrix is the inverse of that matrix. I need a special letter now to show if it's an inverse. So if I call this matrix A, then I'll call this matrix here A with a little -1. That means inverse matrix. And when I multiply them, it makes I. What is that like? Do you remember back here I said 0.5 is the inverse of 2? And what happens when I multiply 0.5 multiply 2? What do I get? 1. So 0.5 is the inverse of 2. And when you multiply them, you make 1. Here, it's the same with matrices. This is the inverse of that. And when I multiply them, I make I, which is like 1. So what's really key now is, if I have a matrix A, how do I find the inverse of it so that I can make the I? You know the formula?
Yeah.
We'll write it down now. But before I go on, I need you to write this down, of course.
So let's say if we swap the second matrices, it will make I, right?
If you multiply them, it makes I. And in fact, you're right also, if you swap them and multiply them, it still makes I.
Okay. Why is this -1? So the A.
Oh, that's a special symbol. When you put a -1 on a matrix, you mean the inverse of it. So for example, I'll just go to the side here. If I write 2, that's just 2. And if I write 2 with a -1, that's called the inverse, which is equal to 0.5 then. So it's a similar idea. So this matrix here is that one.
Yeah.
And then this one here is that one. Okay. So how to calculate or how to find the inverse? The inverse of A, B, C, D. Hey, stop messing. The inverse of A, B, C, D. A, B, C, D. Inverse. Let me just call this A, for example. What you do, you swap these numbers, DA, and then you minus these numbers, minus B, minus C. And also, you multiply by 1 over determinant of A. So don't worry, I'll do an example now. So for example, I want to calculate the inverse of this matrix. What's its inverse? Well, first I do 1 over determinant. I swap these, I multiply these. What's that? 12 minus 2. Okay. And then I swap these, 3, 4, and then I minus these. Minus 1, minus 2. Okay. 12 minus 2 is 10. And if you want, but you don't have to, you can multiply this in to make fractions. So you get 3 over 10 minus 1 over 10 minus 1 over 5 and 2 over 5. So this is the inverse of that matrix. How can you check if your answer is right? What should happen if I multiply these two together? What should I get if I multiply them?
1, 0.
I should get the identity 1, 0, 0, 1. So we can check. 4, 1, 2, 3. 3 over 10 minus 1 over 10 minus 1 over 5, 2 over 5. I'm going to pretend I did this. And I get 1, 0, 0, 1. So what I'm really doing there, if you look at page 16, is question 2, which is a calculation. In question 2, you have to calculate the inverse. You see in number 2 there? I want the inverse of all of those. You see that? Calculating the inverse will be important for the next lesson, because in the next lesson we'll use matrices as a method for solving our two equations. So far we have graphical, elimination, substitution, Gaussian, and then this will be the last method, which is matrix method. So there's 5 in total. Okay. Let's have a look at number 3 now. Oh yeah, a bit of vocabulary just before you go on. You see this matrix here where I swap and change the sign? This is called, it's just vocabulary, this is called the cofactor here. And then we know what this is called the determinant. It's actually 1 over determinant. It's not important, I just wanted to give you that vocabulary. It's called cofactor. Okay. Now let's have a look at number 3. So I give you this matrix, 2x minus 6, 3x plus 1, 2x minus 8, and 3x plus 3. And I want to know, when will this matrix have an inverse? So if this matrix does have an inverse, what do I know about its determinant?
It has to be not 0.
Yeah, determinant is not 0. Now let me be very explicit here at the side here. If A has an inverse, oh yeah, why? Because, well, I'll just again be explicit. This formula for the inverse only works if the determinant is not 0. Because if it was 0, what's the problem? You get 1 over 0, which is bad. So, if A has an inverse, that means determinant of A must not be 0. Okay, and then if A has no inverse, well, what does that mean? Determinant of A was 0. But the reverse is true. If determinant of A equals 0, then that means A has no inverse. If determinant of A is not 0, that means A has an inverse. Does anybody know the symbol in maths that we use when we mean something is possible? Does anyone know that symbol? What does it look like?
Like A.
No, that's the other one. That's for all. Has anyone seen this symbol before?
Yeah.
No. Yeah?
Are you sure that it looks like that?
I am 100% sure. No. I am more than 100% sure. It's a backwards E. This symbol here means exists or possible.
Oh,
Yes. So, if I write this, what I mean is there exists, or in other words, it is possible for an A inverse. You know, it's a short way of writing it. So this symbol means it's possible, or there exists. Okay? So those 1, 2, 3, 4, I can write that as one short rule here. If there's an inverse, that means the determinant is not 0. If there's an inverse, that means the determinant is not 0. If the determinant is not 0, that means there's an inverse. And then the negative is true. If there is no inverse, then that means the determinant is 0. And then here, what's the negative of this? Determinant is 0. So that means, and then the negative here, no inverse. In other words, I'm just saying those 4 statements, you can write it as one statement here. Have you seen this double arrow before? It means you can go that way or that way. Yeah. So anyways, it's really just making the point. Determinant is 0, no inverse. Determinant not 0, there is an inverse. And then the reverse is true. If there's an inverse, determinant is not 0. If there's no inverse, then the determinant is 0. Okay, so you can go both ways, positive and negative. Okay, so back to the question now. So I tell... Oh. Okay. Come on. Are we charging? Yes. Okay, so I tell you that this one here has an inverse. So this one has an inverse.
What's the question?
Find x. It's number 3a. It's 3a, and the question is find x if this has an inverse. Yeah. So if it has an inverse, what do we know about its determinant? Very good. Its determinant is not equal to 0. So the determinant here, 2x minus 6, 3x plus 3, minus 3x plus 1, 2x minus 8, not 0. So if I multiply here, let's see, 6x squared plus 6x minus 18x minus 18 minus 6x squared minus 24x plus 2x minus 8. So that will be 6x squared minus 12x minus 18, minus 18, minus 6x squared minus 22x minus 8, and that's 0. So I have 6x squared minus 12x minus 18 minus 6x squared plus 22x plus 8, not 0. Now what's nice here is that they cancel. So minus 12x plus 22x, that's minus 10x. Minus 18 plus 8 is minus 10, not 0. Minus 10x is not
It's
10.
not minus 10, it's plus 10. Minus 12 plus 10 is plus.
Thank you. Plus, plus. So 10x is not 10, so then x is not 1 then. So that's the answer. This matrix, if it has an inverse, it's only if x is not 1. So if you use any number except 1, it has an inverse. But if you use the number 1, it has no inverse. Okay. Now I'll do an example now where it does not have an inverse. So that's 4a. So I'll just give you a minute to write that down.
You can write it like this.
Is that the answer?
That's the answer, yeah. X is not 1.
This is in case it has an inverse.
This one here is if it has an inverse, yeah.
Write it like this. X is any number except it's like this one.
You almost have it, but not quite. Let me show you. We actually will do that notation soon in the next chapter. But what you're writing to say is x is any number except 1. If you want to write it that way, yeah?
Can we take the whole down?
Is it important?
Yeah.
I see what you've done. You've hesitated and you used the word. It's a bit important.
No, it's going to think a bit.
Oh, I see. Yeah. Who are you talking to? And I'll decide.
It's just my brother.
The one I talk?
Yeah.
Ah, no way. What do you want to talk to him for?
Something about something.
Can I wait until I give you a little break between the classes? Or does it have to be right this second in the middle of matrices?
It's taking longer to speak about that.
It kind of is. Yeah.
I can't watch the video.
Be honest with me. Do you need to speak with him right now? Or could it wait?
Now.
And you're being honest?
Yeah.
What do you think?
Just let him go.
Don't be long. Be quick, okay? Go. I don't want to hear you as well. Go far away. Okay, so I'm going to do 4a now. Oh, you need a minute? Okay.
Yeah.
Sorry, he distracted you, did he? Well, why, if some people already have written this down, maybe you can try 4a before I start it. So in 4a, it does not have an inverse. So that means the determinant equals 0. Okay, do you have that sorted?
Yeah.
Yep. All right. So I'll start it. So if it has an inverse, that means its determinant must equal 0. Must equal 0. So that means minus 8x minus 1 multiply 8 minus 9x plus 9 multiply 8. That must equal 0. So I get minus 64x minus 8 minus 72x plus 72. That must equal 0. So minus 64x minus 8 plus 72x minus 72 must equal 0. So they'll go together. 8x minus 80 must equal 0. So 8x must equal 80. So x must equal 10. the answer.
So if we get 10, there's no inverse.
If x is 10, there's no inverse. Yeah. And since they tell you it has no inverse, then it must be because x is 10. Okay, can I scroll down? Do you need a minute?
Stop to keep up with it.
I know it's
Explain
difficult.
that
It's
advice.
difficult to keep up with me. I know. So there's just one example left to do. Question number 1 is a little too simple for the exam, but I have seen 2, 3, 4, and 5 on the exam. Okay, so I think every exam paper I've seen has a inverse question somewhere in the exam.
It's usually a 1 or a 2.
No, I've seen it in section A and section B. Yeah, it could be a short section A question or part of a bigger section B question. It'd be very strange actually if this wasn't on the exam. So it's a pretty safe question for the exam. It's not too difficult to do. 5 now. So in 5, I ask you to calculate the inverse. So I want the inverse here. So if you remember the formula, I do 1 over determinant. So determinant is minus 9x plus 1 minus 2x plus 8. So I don't even have enough space. Minus x minus 7, 2x plus 9. So it's quite long. Then I swap minus 2x plus 8 minus 9x plus 1. And then I minus x plus 7 minus 2x minus 9. Now I need to simplify this here. It's a bit messy. So if I just do it as some rough work here in red, I have that and then, I have that minus something there. Okay, so that will be 18x squared minus 72x minus 2x plus 8. And then here is 2x squared, minus 2x squared, minus 9x minus 14x and then plus 63. So when I clean that up, I get 20x squared minus 72 minus 2 is minus 74. Minus 74 plus 9 is minus 65 plus 14. So 65, 79, is it? Yeah? I make a mistake?
Minus 7 times plus 9.
Oh, so that should be minus 63 at the end, is it? Okay. Thank you. Okay, I don't quite think I can do this all in my head, so I'll write it out. So I get 18x squared minus 74x plus 8 plus 2x squared, and then that's minus 23x. So with a minus is plus 23x plus 63. Okay, so what's that? 20x squared minus 74 plus 23. What's that? Minus 51?
Yeah, minus 51.
minus 51x plus 71. Okay, so now I have the answer. The answer is 1 over 20x squared minus 51x plus 71 multiply minus 2x plus 8 x plus 7 minus 2x minus 9 and minus 9x plus 1. No, because the question says, as a later exercise, try proving that the inverse always exists for this matrix. So in fact, I know that this matrix will always have an inverse for all values of x, because that's the way I made it. So no matter what number you choose for x, I know that this has an inverse. And the reason I know that is because I know it's impossible for this to be 0. Which we'll see in a later section. So that's the inverse there. If you want, you can put the determinant inside, but you don't have to. But if you want, you can. So you can write this, I won't do it actually, it's too big. But you can write this under each of the 4 if you want. Not necessary. Okay. I have seen this in the exam, but only in section B. In fact, yeah, number 2 you could see in section A, but number 3, 4, and 5 would be more section B. Okay, now let me tell you which ones to do, yeah? Yeah, the question was what's the inverse, and that's the inverse. It just looks messy because there's no numbers, it's just x. But the rule is still the same. You swap, you change the sign, and then you multiply by 1 over the determinant. So that is the inverse of this matrix here. The inverse of this is that. Okay, so the questions I'd like you to do from this, and you can start it now. Still finishing? Yeah, but you have it from Monday. Do you?
Yeah.
Really?
Yeah.
What's your biology homework?
He just gave us
And what is it? What do you have to do?
so,
What's your biology homework?
Do we start questions?
Huh?
It's to do with structure.
I'd say if we did dissect you, we'd get something interesting, huh? I'll pull this in the bin. Yes. Now, don't worry, you have it on Monday. Let's see. We do, yeah, but I want to get you working on these for a few minutes, okay? So, all the questions on the side. So, IJ and then BOST, all on the side. Too much or too little?
Just fine.
It's okay?
Yeah,
that's
Average? It's excellent, all right. So you can start these now. Why don't you practice them for about 5 minutes, and then you can take a break and we'll do the next lesson. So try these for 5 minutes, and then I'll let you take a break. Yes. Oh, I did this one. Oh, that's when you did the phone call.
I believe that this was.
Oh yeah, it's as soon as you left, I said, quickly, let's do the last one, yes. Which one is it now? Let's see what you tried. So you want yes. What B? Did you try? So, you multiply these together. Did you write the answer? Right, multiply and show me your answer, and then I'll show you what to do next.